So here's the drag and drop. And what do we have? Well, we have a bunch of boxes that need to be dragged down there. They are d is equal to x transpose y, or the dot product of x and y, then the dot product of the top parts of the vectors, and then a partitioning of the vectors x and y into a top part and the bottom part. And where do these belong in this annotated algorithm? Well, what does that algorithm do? It computes the dot product. We derived an algorithm like this in week 3. One thing you may notice is that while in the video we discussed the indexing to start at 1, here apparently we start indexing at 0, and you can see that in the quantification here. And now what we need to do is say, well, if we have abstracted away from these details and we think in terms of the dot product of the vectors and then operations with the top and the bottom parts of these vectors, how can we annotate this particular algorithm with this new notation? And what do we have? Well, we notice that d equals the dot product of x and y is just what we want to compute. So that's our post condition. Let's drag that down here. Correct. Okay, let's click that and get that out of the way. Then if we very carefully look at these quantified expressions in various places, we notice that that's just the dot product of the first k elements of x and y. And notice that that's the dot product of the top parts of x and y. So the state of variable d is that it has accumulated the dot product of the top parts. And that happens before the loop starts, at the top of the loop, at the bottom of the loop, therefore every time through the loop, and if we ever come out of the loop, then it happens after the loop is done. And then finally, we notice that we need to take our vector x and partition it into a top part and a bottom part. And initially the top parts of each of the vectors have no elements. So that's actually the equivalent of saying k is equal to 0. Okay, so now we have annotated the algorithm with our new notation. There are a number of things missing. What is missing? Well, we know that here, after we enter the while loop, and every time at the top of the loop body, we also need to indicate that the number of elements in x top and y top is less than n. So that's something that's missing here. Another thing that's missing is the link between what is x of k anyway, and how does that relate to the top and the bottom parts of x. And similarly, how does yk relate to the top and the bottom parts of y? Okay, so what that means is that we need to refine our notation just a little bit more. But hopefully you recognize that our notation allows us to more concisely describe the state of variable d at the various places in this algorithm.